In the previous video, I've mentioned that there are three methods that can help us to find the BFS in a transportation problem. So let's start with the first one, that is called the northwest corner. Just like when you use the simplex algorithm in Operations Research 1 to solve a linear programming problem, here we need a BFS to start the algorithm. So the algorithm has an initial BFS and then it will try to improve that BFS until reaching the optimal solution. So that's why we need a starting BFS. And then for transportation problem, to obtain a BFS, we need to make sure first that the problem is a balanced problem. And then we need to make sure that a BFS has m plus n minus 1 basic variables, and it contains no loop. So this method, northwest corner method, will exactly help us to achieve these two requirements such that we have an initial BFS. So the name of this method comes from the fact that northwest is here in this direction, right? Like in the upper left direction there. And this method works this way. We are going to fill the upper left corner with the value that is as large as possible. So if you look at this transportation table, you can see that the upper left corner that we may fill at this moment is this cell. It is the most northwest corner in the table. And then for that cell, we have the supply of 5 for the first row, and then the first column has the demand of 2. So when we want to fill this cell with the value as large as possible, obviously the largest possible value is 2 because the demand is only 2, so there's no need to send more than 2 units to the first demand point. Okay, so 2 is the largest possible value that we may fill into that cell. Again, because the demand is 2 for that demand point, and the supply is 5, so the largest possible that we can fill to this cell is 2. Now we're going to do the update. If let's say this is the cell 1, 1, so our x11 equals 2, and now we check if x11 equals supply, is it equal? In this case, no. So this is our case. X11 exactly equals D11. So what we fill in the cell is exactly the same with the demand of that demand point. Then what we do is that we are going to cross out the first column. So we cross that column, which means that we will not fill anything anymore in that column. So we cross that column, and then we update the row supply to become 3 because 2 has been taken to satisfy the demand at the demand point 1. Okay, so this is the update rule. So you check if it's exactly the same with the demand, then you cross out the column and update the supply. Now repeat the same thing. Find the upper left corner cell that we may fill and fill that cell with the value as large as possible. So this is the most upper left corner that we have, and then the largest value that we may fill there is 3 because now the first row has the supply 3. The second column has the demand 4, so at most we can fill that cell with 3 only. Okay, because although the demand for this column is 4, the supply from the first row is only 3. So at most you can fill this cell with 3. Now it means that what you fill there is the same with the supply, with the row, right? So that's why you cross the row and then update the column. Okay, you cross the row and then you update the column from 4 now becomes 1 because out of the demand, the original demand of 4 units, 3 have been fulfilled, so you update the demand. The remaining demand becomes 1 unit for column 2. Now repeat the same thing. Find the upper left corner. So now because the first column has been crossed out, the first row has been crossed out, so now this is the most upper left corner that we may fill. Now you see that in this case, the supply for the second row is 1 unit. The remaining demand for the second column is also 1 unit. So the only possible value, the largest possible value that we may fill in that cell is also 1 unit. Now here comes the third update rule. If what you fill in the cell is exactly the same with both the supply and the demand, then you need to cross out either the column or the row. So do not cross out both columns and rows. You only need to cross one of them. So let's say here you decide that you are going to cross the row. That's okay. Now update the column to become 0. This is very important that you only cross out one column or one row. Like this example, you cross out the row, then you update the column. Now it becomes 0. Do not cross both columns and row. And why is this the case? Well, you will see just a little bit later, okay? But keep in mind that you never cross out row and columns both. Now here is the upper left corner, the most upper left corner that you can fill. And the remaining demand for this column is 0. The supply for this row is 3. So the largest possible value that you can fill there is 0. Okay, now you cross out this column. And then if you want to update this to become 3 again, it's fine, but you don't have to because it's still, the value is still 3. Okay. Now let's continue, and now this is the most upper left corner that you may fill. The supply for this row is 3. The demand for that column is 2. So the largest value that we may fill there is 2. Okay, as usual, because it's the same with the demand, so we cross out the column and update the row. Now finally, when you have the very last cell, then you may just fill it with 1 and 1, and the largest value that you can fill there is 1, and then you may cross both. So only at the very last cell that you can cross both you can cross both column and row. Only in the last cell. Okay. Now the reason why you cannot do that before the last cell is that if you cross both row and columns at this place, it means that you will not have 0 in the cell. Now your number of basic variables which will be less than m plus n minus 1, right? Here your m is 3, your n is 4, so 3 plus 4 minus 1, you must have 6 basic variables. 1, 2, 3, 4, 5, 6. If you cross out columns and row at this step, then you will only have 5 basic variables and you will not have a BFS. So that's why before the last cell, you can always cross only either the row or the cell and update the one that you do not cross with 0. Okay, so let's assure ourselves that what we got in the previous slide is a BFS. So first, check, do we have m plus n minus 1 basic variables? Yes, we do, because we have 3 supply points, we have 4 demand points, 3 plus 4 minus 1 is 6, and as in the previous slide, we have counted these basic variables and we have 6 basic variables. So although this is 0, it is a basic variables. The non-basic variables are these empty cells. Okay, and then it does not contain a loop, and then we can check. You can see that these basic variables, they do not contain a loop, because for example here you have 3 consecutive cells here, so it violates the second requirement to become a loop. So this is not a loop. Okay, so these two requirements are fulfilled. We have m plus n minus 1 basic variables, and those basic variables contain no loop. So this is a BFS. So let me give you some quiz questions to check your understanding about this problem. The first one is, what are the values of m and n in this example, where m is the number of supply points and n is the number of demand points. There will be a pause on the video to give you the time to think about the answer for this question, and I will return after the pause. So the correct answer is B. We have 3 supply points and then we have 4 demand points. The next question, suppose we have a BFS that looks like this. Which cell is not a basic variable in this BFS? Same as before, there will be a pause on the video and I will give you the answer after that pause. The answer is A, the cell 2, 3, so it's this. That is a non-basic variable because 2, 2 is a basic variable, 3, 2, 3, 3 is a basic variable. So the first element here indicates the row and the second indicates the column. Now the last quiz question for this section. Can we delete the 0 in the cell 3, 2 in this BFS, and why? There will be a pause on the video and I will give you the answer after that. The answer is no. You cannot delete it, because if you delete this cell, it means that you are saying that this cell 3, 2, or in other words, the variable x32 is a non-basic variable. While in this case, x32 is a basic variable and it has the value of 0. Another thing that you may be easier to imagine is that if you delete this cell, you will not have m plus n minus 1 basic variables. You will only have 1, 2, 3, 4, 5. And it does not satisfy the requirement for solution to become a BFS in a transportation problem. Okay, so be very careful and keep in mind that an empty cell is a non-basic variables. So this empty cells, they are non-basic variables. But if you write 0, it means that it is a basic variable, although the value is 0. Okay, so that's the end for this video, and then in the next one I'm going to talk about the next method that is called the minimum cost method. So see you on the next one. Thank you.